Hi class, this is teacher Jerilyn again, and we are now on our 6th week. Our new topic is about interpreting technical drawing. The learning competencies this week are recognize components, assemblies, or objects as required. Identify dimensions of the key features of the objects depicted in the drawing. Identify and interpret symbols used in the drawing. And check and validate drawing against job requirements or equipment in accordance with standard operating procedures. Well, to guide you along with our topic, here are questions for you. What is a circuit or a schematic diagram? How do you interpret a schematic diagram, and why is it necessary to learn the schematic symbols? Let's start. So a schematic diagram or a circuit diagram consists of symbols representing physical components and lines representing wires or electrical conductors. To learn how to read a circuit diagram like this one, it is necessary to learn what the schematic symbol of a component looks like. Circuit symbols and physical components. So each electronic or electrical component is represented by a symbol. Lines used to connect the symbols represent conductors or wires, and each symbol represents a physical component. So like for example what we have here, this represents a battery symbol, light bulb, a conductor or a wire, physical battery, physical light bulb, and a physical wire. So if this is the battery what the battery looks like, so in our schematic diagram, this is what it looks like. If this is the light bulb, this is what it looks like in our schematic diagram. Same with the physical or the wire in our schematic diagram. Components in a circuit have reference designators or reference used to identify the components in the circuit. This allows the components to easily be referenced in text or a component list. So aside from the symbol, so we also have the reference designators here. So BAT for the battery, and then L for the lamp. So as you can see, there are also numbers. That means that in our schematic diagram, there could be multiple batteries. So if there is one, then BAT 1. If we have another, the second one, BAT 2. Same with the lamp. So we have here parallel circuit example. So in the circuit below, we have two light bulbs, one L1 and L2. Then we have battery 1, the BAT 1. They are connected in parallel to a battery or power source. We have different nodes here. This for the lamp 1, and then the lamp 1 for the second node is the lamp 2. They are all connected with one battery. For our series circuit example, so two light bulbs are connected in series. So again, we have BAT 1, one battery, the lamp 1, and the lamp 2. No nodes are necessary in this circuit to show the bulbs connecting and the battery because single wires are connecting straight to each other. Yes, they are connecting in series or straight to each other. So nodes are only placed if 3 or more wires are connected. We have only one wire here. Here are other common electrical or electronic circuit symbols. So we already discussed earlier that this is the wire used to connect one component to another. We also have wires joined, if you remember our parallel circuit. So one device may be connected to another through wires, and this represented by drawing blobs on the point where they are shorted. Here are the nodes. And then we also have unjoined wires, not joined. The battery for the DC supply circuit, AC supply. Fuse. So it is used in circuits where probability of excessive current flows. So the fuse will break the circuit if excessive current flows and saves the other devices from damage. Transformer circuit, earth ground. Resistor. It is used to restrict the amount of current flow in a device, abbreviated as R. Rheostat and potentiometer. So we also have the capacitor, polarized capacitor, the variable capacitor, diode. So a diode is used to allow electronic current flow to flow in only one direction. LED or light emitting diode, the Zener diode and the photodiode. So we also have the tunnel diode, the Schottky diode. We have the transistor, NPN transistor, PNP transistor. The phototransistor. We also have the voltmeter. It is used to measure voltage at a certain point in the circuit. Ammeter used to measure the current that passes through the circuit at a particular point. Galvanometer is used to measure small currents in order of 1 milliampere or less. Ohmmeter. Resistance of the circuit is measured using ohmmeter. Oscilloscope. Push switch. Push to break switch and a single pole or single throw switch, or also known as the on-off switch. This switch allows the flow of current only when it is kept on. Sometimes it is called SPST. It's abbreviation. Single pole double throw switch. Another is a double pole single throw switch and a double pole double throw switch. Relay, microphone. Earphone. For the loudspeaker, the transducer, amplifier. So it's used to amplify a signal. It is mainly used to represent a whole circuit rather than just one component. Aerial, lighting lamp. So we had discussed this one earlier. Indicator lamp, heater, inductor. So it is used to produce a magnetic field when a certain current is passed through a coil of wire. So the wire is called a soft iron core and have applications in motors and tank circuits. So motor, bell, buzzer. Light independent resistor, the thermistor. We also have the logic gate symbols. So AND gate, NAND gate, OR gate, NOR gate, XOR gate, NOT gate. That's it. So it's very important to understand those symbols, interpret those symbols. So as a recap, circuit or schematic diagrams consists of symbols representing physical components and lines representing wires or electrical conductors. So to learn how to read a circuit diagram, it is necessary to learn what the schematic symbol of a component looks like. It is also necessary to understand how the components are connected in the circuit. And for your activities, answer activities 1 and 2 as well as the reflection on page 10. Once done, send using USB your answers or through Messenger and email. So that will be all for this week, class. Goodbye and keep safe.